now, Chad. I'm excited to have you here, man. I want to thank you for your patience. And I also want to be conscientious that we just got to get this going. I'm going to hand it over to you and let you go with it. Thanks for coming, man. And if anyone has any questions during this meetup, feel free to throw it in the chat and I'll stop Chad at the opportune moment and ask him.
Cool. Yeah, well, definitely. Thanks for inviting me and having me here. I really appreciate it. Maybe I'll give a quick introduction first before we really sort of dive into the fun stuff. My name is Chad Sanderson. I am the product lead for the data platform team at Convoy. Convoy is a late stage startup. So we're on our Series D right now, based out of Seattle. We're a digital freight brokerage or a digital freight marketplace. And it's a two-sided marketplace. So on one side of the marketplace is shippers, and they're trying to move some freight around the country, big businesses like Walmart or Target and folks like that. And then on the other side, you have carriers, and carriers are businesses that own a lot of trucks, and they're trying to take that freight. Convoy sits in the middle and acts as a broker. So we bid on shipments, bid on RFPs, and then for the shipments that we win, we put those into the marketplace, and then we try to optimize the routes of our carriers who are taking those loads. The sort of major value proposition of Convoy is this idea that almost 50% of all the trucks that you see going down the highway every day are actually empty. They're taking loads somewhere, dropping them off, and then they're driving back with nothing in them, and we call that empty miles. And the freight world could be a lot more efficient and cheaper if trucks were always full. That's sort of the hypothesis we have. And so to make that happen, since we have this big network and we understand all of the shipments that are going all around the country, we can say, hey, carrier, you guys want to take a load from Seattle to San Francisco on February 10th. We actually have another load going back from San Francisco to Seattle or San Francisco to Portland, and another one from Portland to Seattle. So the whole trip back and forth, your freight is always full. So we are a very, very heavy machine learning organization for that reason. There's a lot of predictions that we have to make on what should we be pricing shipments at the marketplace at any point in time. We are predicting the ETAs of the freight. That's really important. We have a really huge simulation function, so that when we're actually bidding on the freight to start off with, we have to bid like well in advance, like 3 months or 6 months in advance. So we need to have some idea of what we think is going to happen in the future, what the freight is actually going to be priced at. We have offer relevance models, so all of these things. Really, the main thing that differentiates Convoy from any of the traditional legacy brokers is machine learning and data. So we've taken a very data-centric approach to the evolution of our business. And one of our main focus areas of 2020 or 2021 and 2022 is understanding the impacts of data quality, both on our machine learning models and reporting and analytics and experimentation, and then coming up with a systemic solution to all of these data quality problems. And that's what we're working on now. So Demetrius, I don't know if you want me to keep going or if you want to chat more, or what would be the most effective.
That was awesome. Yeah, that was really cool. I appreciate the intro on that. And so, yeah, did you have a presentation set up for us, or do you want me to ask you questions? How do you want to do it?
Yeah, we could just have, I was thinking it would be more of like an informal chat and we could talk about what we're doing. I do have presentations. I could spin something up, but happy to have a conversation as well.
Yeah. And so I want to get people that are in this call involved in asking questions about some of the complicated problems that you have worked on. And the first thing that comes to mind for me is really like, as you're spinning this up and it's basically, like you said, you're very much a machine learning company. When you built from the ground up this machine learning, and I imagine you started years ago, how did that look? Like, what was the evolution of the platform? Do you have a platform that all the models go out on? And And then I want to get into this idea of trustworthy data that we promised people would be we'd be talking about, and like how you look at data. So first, maybe let's talk about this platform and the evolution, or how you managed to produce so many models and like really create business value out of the models, and then we'll jump into the data.
Yes, great starting point. So Convoy has been a AWS shop since the very beginning. We're in fact, if you look back at sort of the old SageMaker commercials, Convoy was one of the first sort of key customers there. So we've been using SageMaker for a long time. There's a few other sort of deployment mechanisms that we use now. Maybe to give you a quick idea of what the data platform team actually looks at or looks like, because it's quite expansive. We think of ourselves as the end-to-end data infrastructure team, basically. So that's everything from instrumentation to the owners of the ETL process to the data warehouse. So we use Snowflake and we own Snowflake. All of the tools for modeling and orchestration within Snowflake. So we own Airflow, we own dbt. And so that's sort of the data engineering, data infrastructure side. And then we have the data application side that we also own. So that's like data discovery, a metrics layer. We have an internal experimentation platform that we've built, and then also our internal machine learning platform, which is it's a command line for deployments that we built ourselves. So like Kubernetes based, and really easy to like deploy models and schedule new training jobs and things like that. And then we also have an internal feature store as well that we've built. So it's a pretty end-to-end system. Like there's definitely some gaps there. Like we're thinking about like orchestration, specifically machine learning, and where do we use something like a Metaflow or a Flight, and where we want to go on that side. For the last, I would say, year, maybe 2 years, our focus was rapid deployment of models and rapid iteration over models. It's one of the reasons that we built our own sort of command line tool. We just wanted it to be like really, really simple to get models out the door and test them quickly, and like spin up monitoring and all these other types of things. And that's actually been working great. I feel really good about that. Our ability to deploy models is quite mature at this point. But the problem that we started to run into as the volume of models started going up, we also built in some functionality around like shadow testing and like piping shadow traffic to a model and splitting traffic to it and stuff like that. And that was all going well, but we found that there was a more core problem that we needed to address before we started sort of going down the like true MLOps, or I'd say the more mature side of MLOps of pipelines, like thinking about tools like YLabs and sort of model explainability and these types of things. Is we really needed to get our data right first. There were a bunch of models that were like breaking because there was some production change that was made like way upstream, and the engineer never told anybody. And there's like really tight dependencies on some of our production, some of these like production tables. That was like one major problem. Another major problem, sort of along that same vein, is that we weren't really treating any of our data like an API. So it wasn't versioned. It wasn't like, teams just sort of had to deal with what they had to deal with, and hope that they hope that nothing sort of broke down in the communication with the engineering teams. And it did very frequently break down. Then the other problem was a lot of the downstream data sets. So the models that the data models that the machine learning models were trained on were just like fundamentally untrustworthy, was another huge issue. And maybe we can talk about this a bit more, but I think this is actually one of the biggest and most unaddressed problems in machine learning, just in general, where like the result of our sort of current ETL frameworks is that teams are ingesting and using a whole bunch of data that was never intended for machine learning or analytics at all. And then they're reverse engineering business concepts on top of that, and then using that in their training data. And there's not really any monitoring, there's no real quality. And so when stuff breaks, the question's like, well, okay, who owns this? Now there's going to be production implications, and it just becomes a whole mess and a nightmare. So before we went like really far down the let's make our like later stage last mile MLOps process like really good. Let's see if we can focus on the data first.
Wow. There's some hot takes there. I like that. It's pretty sweet. We've got a few questions coming through. I appreciate people asking questions. And dude, I was just trying to think back, like, how did I even find you? And I can't even remember it, but I'm so stoked that I did because just in the first 5 minutes that you've been talking, I'm like really excited for this conversation. So how can you measure data quality KPIs and how do you define that?
Yeah, that is a really good question. So one of the ways that I think you have all the typical data quality measurements. Like the first one I think is most critical, and it's the one that I also see being applied most infrequently. Is like, is there an SLA? Like, does an SLA actually exist, and is the SLA being met? I think that there's a lot of conceptual SLAs. So someone might say, yeah, we need this data. It's pretty important to us. It needs to be here in a timely fashion. And if you have a relatively mature team or a big team, then your data engineering team like might be on the hook for that. But even then, they don't really control the SLA. They just kind of control it. Like if the source data changes, like what the heck are they going to do? They don't, that's not within their sort of their locus of influence. So I think if you have a true SLA, that's really important. I think if you can demonstrate, if you have, in Convoy's case, we have a lot of scenarios where we will run a model multiple times on the same shipment. So we'll price it differently depending on like what happens out in the real world. So let's say, we get an RFP, we'll price it, a bunch of stuff will happen. Maybe there's an external weather event, like a hurricane happens. It will push the ETA of that shipment out, and then we'll price it again. And one of the problems that we have is sometimes the model will make some really bizarre choices when it's going through the sort of first pricing process and the second pricing process. And we needed a way to ensure that the delta was not like too large. And so I think having some way to rerun your training data and ensure that it's not diverging by too large of amount at like different points in time, having some sort of test set, like, and it could be really bizarre too. Like in Convoy's case, we may have a shipment, a test shipment that we run from Atlanta to New York. And that's like a really rare shipment. We probably wouldn't have too many things like that in our system just because it's so long. But if you push that through a model, like the results should be relatively consistent. And what we've found is it's oftentimes not. And it's oftentimes not because the data we're training on can just be like wacky and weird sometimes. So having some framework where it's really easy to create these like test sets and test them at regular intervals, and the various the variations are not like super disparate from each other, I think is another way of measuring it. But right now, my primary focus is on the SLA side of things and ensuring our SLAs are actually good and they can be met.
That's so cool. That's fire. So since you're building models that predict multiple months into the future, how did the model hold up during COVID when we saw wildly out of distribution data, supply chain?
Yeah, very badly, very, very badly. And in fact, it actually led to a huge overhaul of our entire business because we realized that if we're basing all of our prices on something that's happening 6 months in the future, and there's some insane external event our models could never anticipate, and then we just needed to have the ability to go back to our shipper partners and reprice. And we hadn't been doing that for a long time. Like we're taking the tech company of approach of like, we're gonna tell you this is what we're gonna do, and then we're gonna stick by it no matter what. And what our partners out in the industry were doing is they were just going back and repricing and saying like, hey, we need to change this. So we actually changed our business more to fit this scenario than like significantly deviated from how we were doing the modeling. But I do think that there are some. I think one of the issues is that we are not at the time we actually were not able to build the right models because we didn't have the right data. So we were using a lot of like lagging indicators for prediction. We didn't have the ability to like update things in real time, like really quickly. So I think with this new effort that we're working on, that has become a much more central focus. And I'll say something that maybe we can sort of transition down the data quality path, because I think it's a really fascinating application of some of this stuff. Is like Convoy as a business has a really complicated workflow, and by complicated workflow I mean that it's a shipment. The life cycle of a shipment is not linear, so it may start off and a shipper has an RFP, and then maybe 3 months later, they actually award us that RFP, and then it goes out into a marketplace, and then it gets bid on. Maybe you have somebody who wins the bid, and then it gets assigned, and then an ops person will sort of call that carrier to confirm, and maybe they'll like reject it, and it'll go back onto the marketplace, and then the whole process repeats, and then some other things can happen, and it actually gets taken, and maybe it's late. So there's like a lot of sort of winding paths that can happen over the life cycle of a shipment. And the shipment might get priced, or various models might get run on that shipment at different points in time. And one of the challenges we've always had as a business is to answer questions like, we really care about the margin of any particular shipment. How can we root cause why margin for some shipment has changed? So, we said this was the original margin that we think we're going to get on the shipment, and then we actually ended up with this margin. What happened during that arc of a life cycle that caused that to change? And we weren't able to answer that question at all. So that was like another focus of this project as well, is could we think about adding machine learning events as part of a sequence in the history of a shipment, and then being able to point to decisions being made by a model, and root cause, like why they happened, and then also what happened as a result of those decisions being made.
Incredible. And I think that's very similar to another question that was just asked about like the ground truth coming in later than the predictions are made. And so there's another one that is, actually at the end of this question about the ground truth coming in, how do you justify the investments in ML, and how do you deal with that when you're not so sure about if it's actually going to pay off?
Yeah. So the good thing is that Convoy, I think, unlike a lot of other companies that say they're ML driven, is actually ML driven for real. Like, we wouldn't have a business if it wasn't for machine learning. And so because it's such a core value proposition of what we do, it is a lot easier to get leadership buy-in for like optimizations of the model and potentially new models, because we've had a lot of success doing that. The way that we do it, and this is more of I guess, I don't know if you could call it organizational design or framing, but we have a pretty large data team. It's about 70 people, and that includes like data scientists, research scientists, and machine learning engineers. So when there's an opportunity for a brand new model or an optimization of a model, they will lay out all of the potential use cases, how we think it's going to impact the business. We're a very heavy experimentation company as well. So when we deploy a new model, there are some complexities that can happen with this, but generally we like to run an A/B test on, this is the state of the world when we didn't have a model in place and it wasn't sort of doing whatever it's doing, and this is the new state of the world when we do have it. Sometimes we can run both of those states of the world in parallel, just with a feature flag. And sometimes we have to do things that are a little bit more advanced, like where our control group is actually some previous time in the past. But either way, there's some measurement going on of what was the impact of the model compared to a control where the model does not exist. And since that measurement is in place, it gives leadership a lot of confidence that at least we'll be able to know, even in a fuzzy way, how much revenue we're driving, or how much expected revenue we could be driving. So to be concrete, the way that we get a lot of things through is having a great plan, the fact that our business is built on models. So the leadership is already used to making those investments, and having like a really, really good measurement and experimentation plan.
Oh man, I want to ask so many things about this the feature flags and how you use them for ML. But there are other questions, and I want to be respectful of other people in here and not just take it all for myself. What are some examples of the kind of data you deal with and models you build?
Yeah, so we mainly deal with tabular data. In fact, we exclusively deal with tabular data for now. So we don't do, anything like video or images or anything like that. That makes our lives a little bit easier and simpler. We can sort of optimize for that. In terms of the types of models, we've got a lot. Like I was mentioning at the beginning, we have like pricing models, ETAs, offer relevance models. We have simulations, a whole bunch of offline models that run. I would say just about any type of model that outside in the sort of world of a tabular data, we do.
So the next one is like, what are some examples of techniques you use to maintain quality data?
Yes. Okay. So this is the exciting question, and we can kind of get into the nuts and bolts of it here. The core of what we're doing that I think is really interesting and hopefully very interesting to everyone here is this concept of a data contract. And a data contract is basically an agreement between a producer and a consumer that says like, hey, here's the data that I want. Here's the shape that I want it in. And the engineering team says, okay, I'm going to produce this. I'm not going to produce it just for you because it's an API. And so everybody needs to be able to access it. But I understand that I am building it with the data science and the machine learning use case in mind. And we implement those contracts through Apache Kafka. And we have an SDK that we've put together. It's really similar to Protobuf that we've handed off to our engineers. And we actually went through a process almost a year ago, actually over a year ago now, where we put together something called an enterprise data model. And an enterprise data model, if folks are not familiar, is a map of all of the major entities and events in our system from like the business logic, like logical layer. So for example, Convoy really cares about entities like shipments and offers and RFPs and emails and trucks and carriers. And you can sort of go on and on. We have around 120 or 150, somewhere between 120 and 150 entities. And each of those entities ideally corresponds one-to-one with some service. And there's a production table being produced, and each row in that production table corresponds to like an entity. But in a lot of cases, this isn't the case. And some data scientists are sort of building these abstract entities in the data warehouse. Then there's events. These are semantic events. And I like to distinguish between a CRUD event and a semantic event, where a CRUD event is basically an update in a production table for an entity. And a semantic event is like a verb. A entity does something. So a shipment goes off hold. A carrier makes a intent to make a bid. A offer is confirmed. A email is replied to, right? These are all sort of semantic events. And we created this map of the world of how all of the entities relate to each other and how all of the events relate to entities and how they relate to each other. And then we describe the schemas of each one of those entities and each one of those events. And the schemas were based on data scientists in your ideal world. How would you model all of this stuff? And what would you actually need so that you weren't doing all this reverse engineering of business logic in the data warehouse and then things break and you can't depend on it anymore. And so we took that big map and then we went to the engineering team and we gave them this SDK and we said, let's implement everything. Let's start at the stuff that's most important, that's like most critical to our models, and implement it all in production and create this very strong contract, this API. And now the software engineer is the one who's responsible for data quality, not the data scientist, not the ML engineer. They're the ones that can say, oh, I know where we agreed to emit this particular feature. Now we have to change it because my service needs to change, but I am on the hook for communicating that change and making sure everybody knows about it. It's like very, very traceable and versions and all that stuff. So I would say that was probably the largest thing that we did to improve data quality. And we're still in the process of rolling this out. I'd say it's been rolled out to maybe like 30% of our models now, but the difference is night and day. It is like a truly like massive difference in data quality.
So cool. And now I remember how I found out about you. I remember now, it's all coming back. So anyway, another person, Mo, is asking if you can explain a little bit more about the feature store and reuse or use by the business.
Yes. So I'm sure everybody on the call sort of already understands the value of a feature store. The approach that we took was a little different. My perspective, generally when I'm thinking about platforms, my perspective is always to enable the data scientists to move faster, and ideally to not have a tight coupling with software engineering. If we can separate those concerns, so that's basically the same thing I just described, right? We're like decoupling engineering ownership from the data science ownership. So we saw that very tight coupling when it came to features, right? You have data scientists, they do a whole bunch of like manipulation and come up with a training set and all this other stuff. They're like, okay, I have my features now. Then they have to go talk to a software engineer. The software engineer actually has to go and like implement that feature in whatever your code base is. In our case, it was TypeScript. Then you have to pass that back off to the data scientist, and the data scientist has to validate that and say, okay, like this all makes sense, and I'm getting like generally the same outcomes. But the reality that I observed is that, number one, that sort of translation process and the validation process is not perfect. Usually what the data scientist produces and what the engineer produces are not 100% the same. And if there are like slight similarities, like this can result in drift over the long term. That's like one issue. And then the other issue is that it's just a very slow process. It just takes a lot of time. So if you're, in Convoy's case, we were trying to rapidly push out new models. It's the core of our business, right? And going through this sort of, oh, I just have one new feature I need to implement, could take weeks. Sometimes it could take months. It just depends on the schedule, like everybody's schedule having to align, the priorities of the company and all this other stuff. And the way that we thought about it was, there really doesn't need to be a software engineer in the loop there. There doesn't really need to be. We are a very heavy Kafka shop. All the Kafka topics are available to be queried through something like Flink or something else. So we built a platform that allows the data scientists to write SQL or Python. They can query a Kafka topic, and it will produce a feature set. We'll automatically spin up an endpoint. And then there's an SDK that we provide to them where they can like call that endpoint and then get the features at any time. That's basically the internal thing that we built. And what that means is you no longer need a software engineer to build features, right? You can go in and write Flink SQL, create your own features. There's a way to like build window functions and things like that. And yeah, like it works pretty well. But I will say that there is like a cost to building and maintaining your own system. And since we're making this massive data quality shift, some of the things that I really would have liked to invest in more, like around the feature store as an example, kind of have to get pushed down on the priority list a little bit, which is unfortunate.
So given the shift to real-time updating you experienced from COVID, how has that impacted the data quality process?
Honestly, it's made it a lot better. To be frank with you, the great thing about, I think the problem, one of the big issues with not doing real time, doing more of the batch processing, is that it's way harder to detect data quality issues after they happen. A lot of our compute was like, it takes a day or whatever. For some things, it takes like a couple days. And it just takes a long time to figure out, oh, wait, something actually broke here. We need to go back to the engineer and figure out like what broke. And data engineering kind of needs to do the whole like follow the yellow brick road of dependencies all the way back to like a source table somewhere. It's really problematic, and it's something that Convoy is more of a federated. We have sort of federated data quality ownership, and what that means is there's a centralized data engineering team, and that data engineering team basically owns the infra. So they own Snowflake, they own all the things I was describing before. The data science team and like the business analytic, like business intelligence engineers and things like that, they sort of own their domain. And they own like their entity data. And if they're creating like any very important data sets, they own the quality of those. We just do not have a data engineering team that's large enough to take on, ownership of like all the key models in the company because there's so many. That doesn't scale for us. But the downside of that is when you hand over DBT to a group of data folks, and there's not really any sort of guardrails in place, like to ensure that great data architecture is happening. People are just like spinning up new models as fast as they can. Oftentimes not creating like DBT tests. Oftentimes with very bad documentation. Oftentimes where the queries are just written in like a hyper unscalable way and all this type of thing. The ownership of the data quality now being on the data team producing the query, it just gets really, really hard. It gets really hard to say, oh, one of my tests is breaking, and now I need to go figure out what caused that. And oh, wait a second, I'm actually taking 30, I'm joining to 30 tables in this. And so which table is it where that's like the source, and I have to sort of go figure that out myself? It's just a very, very painful process, and it takes a long time. But if you move to this streaming world using data contracts like I just described, the ownership is 100% clear. If something breaks, it's 100% clear, and the data science team doesn't need to worry about it anymore. So I think data quality has risen dramatically because it's actually being owned by the software engineer whose job it is to own quality, like generally speaking, across the other things that they produce. Sorry if that was like a lengthy, rambly answer.
That was perfect. This is another one from me, and there's a ton of other great questions in here. So keep your questions coming and feel free to put it so everyone can see it. I just gotta, selfishly ask one, which is, did the software engineers fight back at these ideas when you were trying to implement them, or were they on board with it?
They were 100% on board. And the reason that they're on board is because they actually don't want people taking tight dependencies on the implementation details of their services. They're like, please don't do this. Like I need, as a software engineer, I need to have the ability to change my service however I need to make sure the service like runs the way that I want it to run. And if I am going to break a critically dependent machine learning model because of the fact that I need to iterate, like this is a really bad thing for me, and it's like a bad thing for the business as well. So when we basically give them the ability to say, hey, just treat all this stuff like an API, and then you don't have to worry about it anymore, they're pretty excited. They're actually pretty excited to do that, and it like role wise, it fits right into their wheelhouse anyways, because they're already admitting a lot of the data. They're just not explicitly capturing it as like making the connection to the semantics. So all the data is there. They absolutely have the ability to do it. It's just one extra step, and then they can ensure that there's like a nice decoupling happening.
Later, I want to talk about security and how you deal with that, or how the software engineers deal with that. But I want to be respectful of some of these other questions that we've got. And there's one asking, Mikhail is asking, fascinating idea, read data contract. So it seems like one of the big value adds of the data contract is that data quality ends up being a responsibility of the software engineer, what we just said. Can you talk about some other value props?
Yes. So one of the other value props is that if you have, this is continuing the idea a little bit, natural continuation of the data contract concept, is that in my perspective, a data contract should be two ways. It's bidirectional. It's between the consumer and the producer, so between the data scientist or the ML engineer and the software engineer, but it's also between the consumer and the data warehouse. And by that, I mean, not only do you need you need a particular event or a particular entity in a particular shape, but you want to go into the data warehouse and then be able to see the data in the shape that you wanted it in originally. One of the problems that we ran into a lot was data scientists would have no idea how to do modeling successfully in a very complex data warehouse. It's just a really, really hard thing to do. Like I need Here is some big 600-line SQL query with 24 joins, which maybe makes it like 1,000 lines. And now I want to go in and add some more columns, and I'm going to figure out how to join all this stuff together and add in another few IDs so that I can create a new entity. And that might take me like 3 months to actually figure out how to do that effectively.
Yeah, and it can get expensive.
Incredibly expensive. It can get incredibly expensive. You know, our Snowflake costs are rising like crazy, like everybody else's is, I'm sure, for one of those reasons. And you get, like, kind of to your point, you get into a huge amount of duplication. There's a lot of like people who come up with similar concepts in their mind, and they go and create those concepts in like a different DBT model. And then you have a question of like, well, what is the source of truth for this data? So if I just want to reuse it instead of rebuilding the wheel, like, what do I do? And in that way, you might get different answers depending on what part of the business you're sort of most familiar with. And that's a really bad thing, obviously. Like, you don't, especially when it comes to critical things like margin. There are places in Convoy, and I don't know if it's happening as much today, but certainly in the past, where depending on what part of the business you're in, and you were asked the question, hey, how many active shippers do we have right now? You would get completely different answers. And that's just based on how people have set up their filters and how they've like built columns and how they've sort of constructed their SQL. So that's like another like really huge problem. And what our perspective is the data warehouse is that should be, it is a product, right? It's a place that it has a code base, it has a function. A lot of people use it in order to do tasks. And so you shouldn't be making changes to a code base if nobody knows about it and they don't understand the impact of it. And DBT kind of sort of solves this problem, but PRs on DBT changes are mainly happening for like, are you breaking anything? And not, does this make sense? And is this the way that the product, which is the data warehouse, should actually look? So the way that we've thought about contracts then and integrating these two ideas together is, on one hand, when you're defining the contract, it is the schema and it is like, what is this event and how does it work and where does it fire? But it's also the modeling as well. And it's also the like logical construction of the event and the entity, like how that would appear in the data warehouse. And so people do all of that in one place. They do all the modeling in one place, all the schema definition in one place. And then we have sort of two sides to this. Basically, on one side, we have the engineer. They build their thing and they say, hey, here's the thing you asked for and here's the schema. There's a translation that happens where a data engineer or a BIE says, all right, I'm going to map your definition of what you wanted to what the data scientist said they needed and the format that it has to appear in. And then once that happens, we can actually automatically generate everything downstream. And then it just becomes like pure consumption. And there's not really that much modeling that needs to happen.
Woo. At what point does a framework need to step back from full automation? Have there been more obvious areas to reduce automation?
Quick, when you're talking about framework, do you mean the thing that I'm kind of describing here, or are you talking about something more specifically to Convoy's business, like the infrastructure or the business itself?
Let's see. So this was a question from Mo. I'm paging Mo, and he says end-to-end for machine learning.
Oh, okay. Yeah, I think that usually our goal is not automation. Usually the goal is efficiency and completeness and accuracy and quality. And if automation turns out to be the best way to achieve those things, then we make an investment in automation. But right now, like even at Convoy, there's a pretty significant number of steps in the process that are still very manual, and I think will always be manual. One example, let me just make sure I'm answering the question. Okay, yes. Like one example is, I kind of mentioned that translation layer that happens between the schemas the engineers produce and what the data science team actually expects. I think there needs to be someone in the middle of that process acting as an arbiter that can determine, like, so for example, let's say if we have some, we have an ID that's called like a phone. So we have an entity called phone, and we have another entity called user. Then a natural next step might be, well, I want a new entity called user phone, and I want to build a brand new model around this concept of a user phone. a data scientist might want that, but there needs to be a human in the loop to decide what is the best way of producing that. Should we just join a whole bunch of stuff together and create this new entity? Do we need to stand up a brand new service? I mean, I think in my example, it's pretty bad because obviously you would just join stuff together. But you might say, do we need a brand new service to do this? Can we just combine a whole bunch of events together? Like there needs to be some critical thought on what is the most ideal and scalable way to take the events and the entities that we have and package them into the format that data science needs. And I think you'll experience that like throughout the entire sort of MLOps, like, you know, workflow, where that type of step makes sense.
So I've got a few questions here before we finish up, and feel free if anyone has any last minute questions that you want to sneak in, now's the time. Speak now or forever hold your peace. And just a reminder for everyone that is joining us, we have on the platform that many of you are probably coming from because it wasn't working. I finally got it working. There is a little button on the left side corner if you go to the front where you can network, and you can be, it just says connect. And from there, you can go and, oh, sorry, that's not the one. But if you're in the chat, you can do a random like meeting with someone who has also been in this talk, and you all can debrief from that. Now, Chad, back to you, man. This has been so cool. I was not ready for the level that you were going to bring. Like, I'm gonna be honest, I did not expect this kind of talk right now, and I'm so excited. I'm so thankful that you've come on here and you've done this. My mind wants to go to war stories because I know that everyone loves war stories, and I feel like you've probably got a few. Yes. Can you tell us some?
Yes. So I'll say that on the data quality side, we have one of the most painful times of my career, I think, was when I was trying to navigate this discrepancy between how we had structured our data engineering team and the day-to-day realities of the data science team. And we basically had a data engineering team that was saying, we do not want to own business logic because we don't understand it. We're the centralized organization. We focus on infrastructure, focus on Snowflake, Airflow. And on the other hand, you had the data science team saying, we are not equipped to take ownership over the queries that we produce. Now, originally, I was sort of the DBT mentality. And the DBT mentality is, look, the data scientist is a software engineer, right? Like, we'll give you a tool where you can do modeling, but you can also do like great testing, and you've got PRs, and you've got everything else. You are a software engineer. And so that means that you do need to take ownership over the code that you write. You do need to treat it with the same rigor that software engineers treat their code, and so on and so forth. And so I was pretty like, we definitely had some battles back and forth on where that ownership should lie. And my perspective originally was, well, if you guys don't want to do this, that's not my problem. Like, you just need to do it. Like, it's no different from a software engineer saying, I don't want to own quality. Like, the answer to that would be like, tough luck, man. Like, it's part of your job. But what I've come around to since then, and that took me a long time to get through that phase and sort of evolve my thinking there. What I've come around to is that the data scientist actually is not a software engineer. The data scientist is, they may write code, but they're more like an analyst than someone who is building code for the purposes of, they're not sort of building code for the purpose of like maintenance and engineering and like really great engineering best practices and scalability and all of those things. Their job is to deliver business value, and they're trying to deliver business value as fast as they possibly can. And that is fundamentally at odds with quality. It's just not the same thing. Like, delivering business value quickly and quality are always going to be at odds with each other. And that's one of the reasons why the framework I settled on is, well, let's just let the people who are good at quality, that's what their job is, do that work. And data science really, like, what is the ideal framework so that data scientists shouldn't have to do that work? And in fact, what I'm leaning towards more every day is that the more we can push data science out of the, like, really getting deep into code ownership, the better. So I don't know if you've heard of this idea of like metrics layers, but to me, like the metrics layer, the feature store, all of that is really similar. And in the ideal world, you're mainly focusing on taking existing event streams and applying business logic on top of that. And in the future, if you have this upstream source where you're defining all the business logic and you're defining the business concepts, like this is a truck, this is a shipment, here's all the entities and events, and here's what they mean, then there's not really a reason why your downstream tools, your feature stores and your metrics layers can't inherit all of that metadata. And then teams are just working with metadata now. You're working with like aggregations and combinations of different metadata. Of course, you can apply more complex things on top of that if you want, but that's sort of the world that I envision. The more that we can push the quality onto engineering, the better.
I love that idea. Like, hey, do your job. This is part of the job. And now you've come around to like, well, maybe if you're a data scientist, it's not part of your job. And so talk to me a little bit about this metrics layer before we go.
Yeah. So the idea of a metrics layer is really similar to a feature store, except it's more for, it's basically like a feature store, but for batch like experimentation and analytics use cases. So what we have at Convoy today is a Git repo where a data scientist can create a SQL definition. And a definition is a combination of a SQL file and a YAML file, which just has like metadata about the metric. So it might be, program margin. Here's how it's calculated. If it goes up, it's a good thing. If it goes down, it's a bad thing. Here's the person who owns that definition. Like maybe it's the finance team, maybe it's somebody else, but like that definition exists somewhere. And that's like, and then there's we have an interface. Like basically we index all of these metrics and we make them discoverable. Our first application of the metrics layer was for experimentation. And so what we do is we basically say, anytime someone is running an experiment, we have all of the IDs of every entity in that experiment. So if you're deploying like I mentioned earlier, deploying like, a brand new model or a new iteration of a model, and you sort of have the old iteration of the model, then you would capture all the IDs of each entity that would experience the control and treatment versions, dump that into the data warehouse. Then you would compute, we would spin up a new Airflow job and join the metrics definition to the IDs that were in each experience, compute the actual metric, and then what we're left with is and then aggregate it, and then you have all of the users or all of the entities for control and for treatment, all the metrics, all the business metrics that are important, and then there would be a delta between the two groups. You run a statistical test on top of that to see how significant that delta is, and then what you're left with is it's either really significant or it's not significant at all, and that's how you can sort of make these like rapid choices. So we do that. We do that for every change. I'll say not every change, but most of our major feature changes, and that includes our model changes. And the metric store is really tightly integrated to that. But what we're working on right now, and hopefully this is done by the end of Q1, is that we're extracting the metrics layer and we're turning it into an API. And basically saying anytime a metric definition or a dimensional definition is created in this surface, we produce a cube. The cube has every combination, like every possible slice of every metric and every dimension, like where it's applicable. And then anything can consume that API. My perspective is that the metrics layer and the feature store are fundamentally the exact same thing, just for different use cases. One is for real-time serving or not so real-time ML serving, and then the other one is for experimentation and like reporting and analytics and things like that. So there's not a real reason why you can't have a single surface, which I will call the metrics layer, and then you just pipe your features or your metrics out to whatever tool needs to consume them.
I'm just glad you didn't call it another store name. We've got enough stores already, and layer is a better fit. So, dude, Chad, thanks, man. This has been really cool. I am thoroughly surprised, and I am so grateful that you came on here and just schooled me. Thank you for everybody that is joining us. I threw in the chat right now, if you're in Zoom, a link to if you want to do the networking part right now. that's something new we're trying. It's with this new platform that we've got. And hopefully next time we do one of these meetups, I can get the platform streaming on time and correctly. Today it was the first time, so it was a little bit of a mess up. But if you want to just go in there and randomly get paired up with someone that you can talk to about all this cool stuff Chad was talking about, jump in there, get paired up with someone, have a little chat, meet somebody, hopefully that thinks the same way you do or challenges some of your ideas. And this will be, this is about it. Chad, you got any last words? Are you guys hiring? Anything you want to promote? Any of that good stuff?
We are hiring. We are hiring all the time.
Yeah, I figured.
Yes. Please reach out to me if you're interested, both in terms of working on my team, which is a data platform team, and we work on all the ML infrastructure, or if you're interested in working on any of the customer-facing machine learning teams. Please reach out, LinkedIn or email, either one.
Cool. Very cool. And we'll leave all that information in the description below if you're watching this in the future. For now, that's all we've got. Thanks everyone for joining and the patience with me at the beginning on the mix-up. Chad, I appreciate it, man. I really appreciate this.
Thanks for having me.